And welcome back to this final segment of battery shaving discussion and predictor selection discussions. What I'm going to do now is I will show a third mode of variable shaving that in some cases can be used at the very end of the process to really fine-tune the list of predictors that survived all of the previous variable selection processes. To basically remind you, now we reduced the list of predictors down to 13. And let's see what else can be done with this. And again, I'm running the same run here. So I'm going to switch to battery again, find battery shaving. And notice, in addition to top and the bottom mode, there's also a third mode known as battery error, shaving error. What shaving error does, it conducts a very long shaving process where instead of just looking at the most important variable as shaving from the top does, or the least important variable as shaving at the bottom does, the shaving error looks at removing all available predictors one at a time. So it tries to remove any available predictor from the list. Then it identifies the predictor that is least harmful as far as being removed. And then it proceeds by repeating the same process over and over again. So you're getting basically some kind of a double loop here. So I'm going to run battery shaving error. Just in terms of, so let me click on the Start button. And at this point, I'm running 91 individual runs. And 91 is the overall number of runs that a cart will try in order to do the double loop, a shaving error process, starting with a list of only 13 predictors. Now, needless to say is that shaving error is a very expensive battery operation, so you don't want to start shaving error at the very beginning of your process when you have hundreds of predictors, because it will be just combinatorially a very lengthy process and you may run out of time or resources. So usually we preserve shaving error for the very end of the modeling runs when we need to do this final fine-tuning of all of the things that we have discovered so far. So let's just wait for it to come up with the final report here. Okay, so I have this final window here. And notice, as I do shaving error, again, I start with the list of 13 predictors, and then I try removal of each of those 13 one at a time. The end result is that if I remove a word frequency hour, then I'll have the best next model available. And as you do that, what happens is that it actually finds a model that has a better performance. And only once you go to 8 or fewer predictors, then the performance is starting to degrade again. So I've started with 0.17 by basically reducing the number of predictors by almost 50%. I still stay within reasonable relative cost here, and this final model has only 8 available predictors. So when I double click on that, I can actually see the resulting tree, and if you click on the summary, you can actually identify that there are only 8 predictors that survived this variable selection process, and we're still getting a very good performance in terms of relative cost and also in terms of area under ROC curve. So this final list, again, can be highlighted, highlighted, opened up as a separate notepad window, and saved for future use as a keep 8. and also submit it such that you now have the complete list of 8 predictors that are used in the final model here. And as you can see, we've started with 57 predictors. Then we ran shaving from the top to make sure that all of the top most important predictors really are important. Then we proceeded by running shaving from the bottom to eliminate all of the noise in the relevant predictors. And we finally fine-tuned the entire list by doing a lengthy shaving error step such that the final list of 8 predictors has the best predictive capability and preserves all of the modeling performance and all of the other. And in fact, it actually improved model performance to a certain extent. And this is a very typical scenario. Again, this was a very simple toy example. I didn't really focus on doing all of the fine individual comparisons and studying. But in real life, whenever you will start with very lengthy, large lists of predictors, then you should always try some of these interesting automation techniques, shaving from the top, shaving from the bottom, and the shaving error in some cases. And in all of the consulting applications that we ran in-house, we've always found that there's a very nice way to eliminate the vast majority of predictors and then focus on the core set that really is important. I used Cart as an illustration here. The variable shaving can be done in any other data mining engine, most notably TreeNet, that has an even better ways to communicate variable importance and is a lot deeper way to look at the contribution of all of the available predictors. But you can also do it in Mars, you can do it in Random Forest, and you can do it in all these other engines that we keep on adding to the SPM suite. So hopefully you found it useful, and in our practice, I would say battery shaving is probably the most frequently used battery from all of the batteries available out there. It's also the most promising and the most beneficial in terms of getting the final results. Thank you.